Hi, my name is Julia Gottschall, and it's my pleasure to share my thoughts on the gaps and needs for air-sea observations in the context of offshore wind energy. First, I would like to address the question which measurements, and in particular wind measurements, we need for the realization of offshore wind energy. In short, we are interested in the measurement of the representative inflow at wind turbine or wind farm level. So this is the horizontal wind speed. It's a hub height of the turbine or a vertical wind shear over the rotor area, so the horizontal wind speed at different height levels. This is for single wind turbine, but when we look at the whole wind farm or a wind farm cluster consisting of many wind turbines, we would look at the inflow at a particular point, normally a corner point in wind flow direction for this larger setup. We are also interested in further atmospheric or air observations, however, rather as secondary measurement variables. So these other variables clearly don't have the same relevance as the wind measurements in the context of offshore wind energy. Also, sea observations are of interest. Normally, they are part of the so-called mid-ocean conditions, which are assessed for site suitability studies. Here, however, we can say that the ocean part, so the oceanographic parameters being part of the mid-ocean conditions, are normally governed by modeling activities. So they are modeled. Measurements or observations are only used to calibrate the models, which is exactly the other way around for the wind part, where the project development really relies on on-site wind measurements or observations, at least for a shorter period. So we can say that the wind measurements are key to the development of wind energy projects. This is the one hand side. On the other hand side, on-site offshore wind measurements, so really measuring the wind conditions at every site are very costly, in particular in the early planning phase of the wind project, really long before any installation is proceeded. Offshore measuring masts are for this purpose not cost efficient and are practically not built any longer, although measuring masts are really the standard technologies for measuring the wind and had been used for a long time, in particular onshore. The alternative to the masts, or really the substitute technology, are today so-called floating lidar systems, in short FLS, which can be considered as a de facto standard technology for wind resource measurements in the offshore wind industry. A floating lidar system is a lidar remote sensing device vertically profiling on a floating platform, or concretely a buoy, as you can see it here on the picture. There are some pre-normative guidelines available for this kind of technology, and an IEC technical specification is currently under development. Another offshore wind measuring technology is referred to as scanning wind lidar. A scanning lidar is again a lidar remote sensing device, but in this design scanning horizontally from a platform or also the coast to offshore, either as a single instrument or dual Doppler setup. These kinds of applications are particularly used or of interest in some parts of the world for some industries where it is, for example, difficult to get permissions to anchor a buoy just for the wind measurements. So there are some areas where the industry looks more into floating lidar. In some other parts of the industry, it's really this technology. So there's a kind of alternative to go for the one or the other, but these two technologies can also be seen in a complementary way. also for scanning LiDAR, there are guidelines developed, and particular, there's an initiative to develop recommended practices with an IA Wind Task 52, which was recently kicked off in May 22 and is managed by Fraunhofer IWES as operating agent. As a last thought, well, it's not just about technology, it's also about the data that is generated with all these measurement devices. And what we observe already for Europe, and you see this picture here is from a study we conducted for Northern Europe, is that all these wind energy project development activities generate a lot of data, more and more wind resource data sets that really can be considered as high quality wind speed measurement data sets for these particular heights of interest, and normally with durations of 1 to 2 years. These data sets correspond to valuable databases, for example, for model validation, and actually for validating exactly those models, which are also again in turn of high interest for the wind industry, including reanalysis data sets, numerical weather prediction models, and similar. So there's really a push for these activities with the data that are collected and in many cases also provided for research and further activities. With this last thought, I would like to close my presentation. You see my contact details, and I would like to thank you for your attention at this point.